FC prime equals 27 megapascal and FY equals 420 megapascal. So this is the section of the beam with an effective depth. So this is effective depth only. So dito lang siya. With effective depth of 600 mm and the width of 375 mm, and it is only 10 reinforced with 4 pieces and 8 mm diameter bar. So in solving them involving ultimate strength design, this is the general step. So first, we assume a yielding condition. Pag sinabi natin yielding condition, nag-yield yung steel mo. So we assume that the F sub S is greater than or equal to F sub Y. And we state and equate that compression is equal to the tension. With this condition, we can solve for your alpha. And what is again alpha? From our discussion last meeting, ano ang alpha? So alpha is the depth of your stress block, equivalent stress block of your in the stress diagram. So after solving for alpha, so you can use this equation in solving for alpha. In yielding, we use your F sub Y. Kasi nag-yield siya. So 0.85 FC prime alpha B equals ASFY because yielding condition. We assume yielding condition. Next is to check whether this still yields. So sa first step, nag-assume lang tayo pero hindi natin sigurado kung nag-yield ba talaga yung concrete mo. So we check if Fs is greater than or equal to your Fy. If yes, we accept alpha or the value of alpha. So you can check by using the formula for Fs, that is equal to quantity 600, quantity D minus C all over C. And what is C in the formula? So this is the distance from your compression fiber to your neutral axis in the stress block. So kailangan nating alamin yung value ng C. Then after that, kung hindi naman siya nag-yield, let's say for example, Fs is less than Fy, therefore hindi nag-yield yung steel mo, we use also the non-yielding condition. So balik tayo sa number 1, pero ang gagamitin natin is Fs because this is non-yielding condition. So Fs ang gagamitin natin dyan. Then solve for the value of your alpha. So determine the type of failure to know the value of the reduction factor or your phi. So malalaman natin kung compression failure ba siya, tension, or the transition phase. So kailangan nating alamin so that we can solve or we know the value of your reduction factor. So compression controlled ba siya, tension controlled, or transition failure. Then after that, we can solve for the value of your VMM. So this VMM is actually your MU or M sub U. So this can be used in the designing of your beam, which is your design strength. So we can use this using the following formulas. So Vm equals phi 0.85 Fc prime alpha b multiplied by the quantity d minus alpha over 2. Or you can use phi ESFY quantity d minus alpha over 2 if yielding, and you use ASFS if non-yielding. So this is the general step. So you can take a screenshot so that for the future you can you know how to solve ultimate strength design problems. Okay, so let's try to solve the problem. So first we have to so we assume the what do you call this, your stress block and your strain diagram. So this is 428. This is the value of D. This is the value of B. So let's assume that this is the neutral axis. And your stress block. So this is tension. That is equals to ESFY. And your compression is equals to 0.85 Fc prime alpha B. This is the value of your alpha. So what else? Your strain diagram. So this is 0.003, assuming that it, and then we have epsilon sub t is equals to Fs over Es. And this is the value of your C from the extreme fiber up to the Na. So what else? So this is your stress block. And your strain diagram. So step 1, solve for alpha from C equals T, assuming it yields, still yields. So 0.85 Fc prime alpha B is equals to ES Fy because we assume that it still yields. So Fy ang gagamitin natin. So alpha equals ES Fy 0.85 Fc prime B. So what is AS? 4 times pi over 4 D squared. So yung area ng bakal, what is our Fy from the problem? This is 420. 0.85, what is Fc prime? 32. Tama ba? Hindi. May isang problem ito. 420, 27. This is 27. And the value of B, 375. Kindly compute. $120.2. So this is your alpha. So second step, we check if still yields. So using the formula Fs 600 D minus C over C. We cannot directly solve Fs because we want first to solve for C. And from the formula, we can use the formula alpha equals C beta 1. Diba? So we can solve for C, that is C equals alpha divided by beta 1. And what is beta 1? What is beta 1 for checking? Anong beta 1 natin? We check for the value of beta 1 using the table. So, yung table natin? Beta 1. So, from our table, so isulat ko na lang FC prime, the value of beta 1 from the NSCP 2015 ito. If FC prime is between 17 and 28, so beta 1 is 0.85. If FC prime is between 55 and 28, formula is 0.85 minus, 0.85 minus quantity 0.05 FC prime minus 28 all over 7. So i-check nyo sa NSCP ito, meron sa NSCP. If FC prime is greater than 55, your beta 1 is 0.65. So that is the value of, those are the values of your beta 1. So our FC prime, ano yung FC prime natin is equals to 27. So that is between 17 and 28. So we get, therefore, beta 1 is equals to 0.85. So we can now solve for the value of Fs. So Fs equals 600. What is the value of D? Ano ang value ng D natin? Ganda kanina. 600. 600 minus the value of C, which is alpha, divided by beta 1, all over the value of C, which is alpha, divided by beta 1. Solve for Fs. What is Fs? Pakikalkyo. Anong Fs? Point sila? 26. So, other pa-calcu, baka may iba pa kayong nakuha. So, this is MPA. So, what is now our assumption? Fs, then Fy. Tama sa iba? 1945.76. So, since Fs is greater than Fy, tama yung assumption natin na still yields. So, it yields. So, next step is to determine the type of failure. Using the formula epsilon sub s equals 0.003 P minus C over C. So, given naman lahat, pa-compute kung ano ang epsilon sub s. So, this is 600 minus alpha over beta 1 over alpha over beta 1. So, what is epsilon sub s? Pa-compute ako. Pa-compute yung kailangan epsilon sub s. Ilan?
0.009.
0.009. So again, from our table, so pa-screenshot na para mabura ko na. From our table, epsilon. So, saan na yung table natin? So, 0.009 yung epsilon sub s natin. So, from our table, compression controlled, tension controlled, and the transition. If epsilon sub t is less than or equal to epsilon ty, this is epsilon t greater than or equal 0.005. Epsilon ty is between epsilon t and 0.005. Your fee is 0.65 for beam and tied column. Ito naman is for spiral column. 0.9 And this is formula 0.65 plus 0.25 epsilon t minus epsilon ty over 0.005 epsilon ty. So your 0.009 is greater than or equal to 0.005. So that is, therefore, ito siya pupunta sa tension controlled 0.9 sa table natin. So your phi equals 0.9. So last step, solve for phi mn. So this is now your design strength, phi mn. So let's say we use the first formula, phi 0.85 fc prime alpha b d minus alpha over 2 equals to 0.9, 0.85, 27, 120.2, 375, 150, 600 minus 120.2 over 2. So what is your phi mn? So since yielding, we can use also, or we can use also the formula for yielding, phi mn equals phi ASFY d minus alpha over 2. 0.9. What is Fs? IES 4 multiplied by pi over 2, 28 squared, 420, 600 minus 120.2 over 2. So what is phi mn? Can you compute kung ilan? Ilan? 65. $659, 925, ganyan. So this is Newton mm. Or you can divide 1,000 squared. So this is 502 kilonewton meter. Itong isa, 502.66 kilonewton meter. So more or less dapat medyo magkalapit lang, kung hindi masyadong, dapat hindi malaki yung agwat mo.
Sir, 502,656,222.
222, ganyan,
Yes, sir. Yes, sir.
Newton meter, or 502.66 kilonewton meter. So ibig sabihin, yan lang ang kayang hawakan ng beam mo. Pag lumampas yung moment na yan, your beam will fail. So that is the design strength of your beam. So any question regarding the first example? So you take a screenshot. Before we go to the next example, pwede pang isa. Okay, so let's move on with the next sample. So the saying, determine the design strength as per NSCP 2015 of the beam section that is shown. So you can use FC prime 32 MPa and Fy is 420 MPa. So you have a beam section with a width of 250 and an effective depth of 380 that is reinforced with 4 pieces 16 mm bars. The same steps. So ito yun na yung gagamitin natin as the general step in solving for the ultimate strength design of your beam. So first, so that's 416, 380, and 250. Reinforced with 416 mm diameter bar. What is FC prime? 32, 420. So we assume that this is the neutral axis. So your stress block. So this is C. This is T. This is alpha. This is C na maliit. .003. And this is Fs over Es. So first step, assume yielding condition of your steel. So solve for alpha. 0.85 Fc prime alpha B equals ASFY So your alpha is ASFY over 0.85 FC prime B. So we have 4 pieces, 16 mm. Fy is 420.85, FC prime is 32, and your B is 250. So alpha equals ilan? Ilan ang alpha natin? Ilan? Pa-compute?
Sir, yung na-compute ko pa 49.67.
49.67. So next, check if still yields. So that is Fs equals 600 D minus C over C, where C equals to alpha over beta 1. Since your beta 1, mula dun sa ating table kanina, so you check. So in SCP 2015, your FC prime, that is equals to 32, is between 55 and 28. So therefore, your beta 1 will be equal to the formula 0.85 minus quantity 0.05 FC prime minus 28 over 7. So that is 0.85 minus 0.05, 32 minus 28 over 7. So what is our beta 1? What is the value of beta 1?
0.82, sir.
0.82. So we can now solve for Fs, that is equal to 600. Your D is 380 minus C, that is alpha over beta 1 over alpha over beta 1. So Fs equals Ilan sa FS?
3164.04.
3164 point? Ilan? Point?
0.04 po.
04 MPa. So from here, Fs is again greater than Fy. So assumption is correct. Assumption is correct. Your still yields. So correct tayo sa pag-assume sa number 1. So tama yung value natin ng alpha. So assuming that is not correct, let's say for example, your Fs is less than Fy, balik ka ulit sa number 1. Kaya lang, sa number 1, ang palitan mo is ito. Yung Fy, palitan mo na siya ng Fs. Okay, so next step. Determine the type of failure. To know the value of your reduction factor. So epsilon s, that is equals to 0.003 d minus c over c. So 0.003 380 minus the value of your alpha over beta 1 divided by alpha over beta 1. Ilan na yung alpha kanina? Alpha is equals to 49.67. Beta 1 is equals to 0.82. So what is epsilon s?
Zero point 16.
Point
16 po.
0.16, ganyan.
Yes, sir.
So this is again greater than 0.005. So that is tension controlled failure. So we use P equals 0.9. So we can now solve
0.016 po pala, sir.
ilan? 0.
0.016 po.
0.16, ganyan. So greater than pa rin.
Apo.
So greater than 0.005 pa rin. So your failure is tension controlled and your phi is 0.9. So we can now solve for phi mn. So phi mn equals phi 0.85 fc prime alpha b d minus alpha over 2. Or you can use the formula if yielding phi mn, phi as fy d minus alpha over 2. So what is mn or what is phi mn? Kahit ano sa dalawa pwede niyong gamitin. Because this is a couple ito, coupling ito. This is compression, this is intention. Kung maalala nyo kanina dun sa ating stress block, yan siya. So this is T and this is C. Itong part kasi na ito is your alpha. Therefore, and this is D, di ba? This is the effective depth. So itong distance na ito is D minus alpha over 2. D minus alpha over 2. So ito yung moment arm niya, kaya merong D minus alpha over 2 dito. And P is equals to AS Fy. So pwedeng mag-moment ka at C. So kapag nag-moment ka at C, AS Fy multiplied by the moment arm, D minus alpha over 2. Kung dito ka naman nag-moment sa T, so yung C is equals to 0.85 FC prime alpha B. So this is C multiplied by the moment arm, D minus alpha over 2. So itong part na ito is your compression. Itong part na ito is your tension. Itong part na ito is the moment arm. Kaya kahit alin sa dalawa ang pwedeng ang gamitin nyo, pwede lang. So pa-compute kung tama, dapat halos magkaparehas. So ang difference niya lang yan is yung nagra-round tayo. Katulad nito, ni-round off natin ito. Kapag hindi tayo nag-round off, itong dalawang ito is parehas lang siya. Pati itong beta 1, nag-round off tayo kanina. So what is VMN? Niya? Plan. Anong nakuha niyo?
Sir, 107,963,198.
Newton mm.
Tapos po sa isa, sir, 107,972,162.
So this is Newton mm. Pero kung di tayo nag-ground dito, more or less parehas na parehas itong dalawang ito pag Newton mm. So we can convert into kilonewton meter, that is 107.96 kilonewton meter. This is 107.97 kilonewton meter. So halos parehas lang naman. So any question or clarification regarding the problems? So you take a screenshot and you try this one for 15 minutes. Kaya na siguro to. Yung susunod. No problem. So you try for 20 minutes or 15 minutes. Then we will see later on